Hello, I'm Pascal Thubert. I'm Principal Engineer at Cisco Systems. Cisco is one of the major hardware and software vendors for Internet technologies. And during my 20 years at Cisco, I've been doing research, prototyping, I've been doing production code for Cisco routers and switches, and I'm now part of the CTO organization, focusing on standardization and advanced technologies. In the last 10 years, I actively contributed to the elaboration of IETF standards for 6LoWPAN, RPL, and this is the combination of choice for routing and build scalable wireless mesh networks in the IoT. Now, the WISN Alliance focuses on smart grid networks and builds meshes of thousands of nodes. The WISN Alliance defines a standard that integrates RPL, 6LoWPAN neighbor discovery, 6LoWPAN header compression, and CoAP, and produces a conformance test suite to ensure the interoperability of products from different vendors. With this, RPL may very well be the most deployed routing protocol in the world, as it is implemented in millions of smart meters that are deployed by North American utilities. RPL is of special interest for a number of innovations that were necessary to optimize the use of spectrum and energy in constrained environment. On the one hand, RPL allows you to build very large IPv6 subnets by using routing instead of bridging inside the subnet to eliminate the need of broadcast. This is what we call route over. Also, RPL is anisotropic, meaning that it is directional, more precisely polar, and it only optimizes a certain set of routes along a single directed acyclic graph. This saves energy and limits the number of states that have to be maintained at the expense of extra route stretch. And this extra route stretch depends on the RPL mode of operation, which can be either storing mode or non-storing mode. RPL is also unique in that it is proactive to form the routing states, and as most routing protocols are, but it is reactive or lazy for route maintenance, leveraging the data plane to detect routing anomalies and solve them. RPL standards are still evolving to include extreme use cases, from fully reactive approaches that derive from AODV to SDN-like centrally computed optimization with the new RPL route projection. To meet a WISN requirement for very low-power devices, we are now extending 6LoWPAN ND to cover not only unicast but also anycast and multicast addresses, and we are redistributing those addresses into RPL. To conclude, despite all those innovations, RPL still suffers from a lack of awareness of its qualities outside of the IoT community, and this may limit its expansion. But in fact, it is a very versatile routing protocol that can be used in many environments, from IoT devices to big iron routers and switches, and even in very dynamic swarming topologies, or in deployment that could benefit from its auto-configuring properties.